Welcome back to Built by Machines, where we uncover the massive systems behind everyday products. Today, we explore the incredible process behind something deceptively simple: sugar. It's sweet, it's everywhere, and it's produced in some of the most high-volume, high-efficiency industrial operations on Earth. This is how millions of tons of sugar are processed, from muddy roots and thick stalks to pure white crystals ready to ship worldwide. Let's get started. Sugar production starts with two key crops: sugarcane and sugar beets. Sugarcane grows in warm climates and resembles bamboo. It's about 70% water and 12 to 14% sucrose. Sugar beets, used in colder regions, contain about 16 to 18% sucrose and are grown underground like carrots. Massive GPS-guided harvesters are used to cut cane and pull beets from the ground. These machines can process 30 to 40 tons of crop per hour and work in fleets. The harvested material is loaded into semi-trucks and rushed to the processing plant because sugar content begins to degrade within hours. At the factory, raw materials go through initial cleaning. Sugarcane is washed under high-pressure water jets to remove mud, leaves, and rocks. Beets are sent through flumes, water channels that float them to washing drums, where dirt and stones are screened out. Next, they're chopped. Sugarcane is cut into short pieces called billets. Beets are sliced into long, thin strips called cassettes, maximizing surface area for juice extraction. This is where the real magic begins: extracting the sugar juice. For cane, it goes through a series of heavy-duty mills with grooved rollers. Each roller applies massive pressure, up to 500 tons, to squeeze out the juice. Water is sprayed during crushing, called imbibition, to wash out more sugar from the fibers. The leftover crushed fiber, called bagasse, is stored and burned later to generate steam and power for the factory, making many sugar mills energy self-sufficient. For beets, the cassettes enter diffusers, tall stainless steel towers where hot water circulates upward while the beets move downward. This countercurrent system maximizes sugar extraction, similar to how coffee is brewed. Raw juice is full of impurities, from soil particles to plant proteins and waxes. So, the next phase is clarification. Factories use the lime and heat method. Milk of lime or calcium hydroxide is added to the juice. The mixture is heated to about 90 to 105 degrees Celsius or 195 to 220 degrees Fahrenheit. Lime reacts with non-sugar compounds, forming insoluble particles. The juice is pumped into settling tanks or clarifiers, where solids settle out as mud. Some plants also use flotation units or high-speed disc filters for faster separation. The remaining muddy residue, called filter cake, is pressed and sold as fertilizer. The purified juice is still too watery, over 85% water. So now it goes into multi-effect evaporators. These consist of 4 to 6 large chambers operating under vacuum. Steam is injected into the first vessel, boiling the juice at reduced pressure. The vapor from each stage heats the next, saving energy. By the end, the juice is reduced to a thick syrup containing around 60 to 65% sugar. This syrup, now called masaquite, is ready to crystallize. Crystallization is the core of sugar production. The syrup is fed into large, vacuum boiling pans where it's carefully seeded with tiny sugar crystals. Under reduced pressure and controlled temperature, the crystals grow slowly. This is a delicate process. Too fast and crystals are uneven. Too slow and it's inefficient. Operators monitor crystal growth visually through sight glasses and adjust steam, vacuum, and seeding to hit the perfect size. Once the crystals reach optimal size, the mixture is pumped into centrifuges. These machines spin at over 1,000 revolutions per minute. The sugar crystals are forced outward, while molasses is expelled through tiny perforations. After spinning, crystals are sprayed with hot water or steam to remove any residual syrup, leaving them bright and clean. The molasses isn't wasted. It's either reprocessed for more sugar or sold for use in animal feed, alcohol production, or yeast cultivation. Freshly spun sugar is still damp, so it's conveyed to fluidized bed dryers. Hot, dry air is blown up through a vibrating screen, gently drying the crystals without melting or damaging them. After drying, sugar travels through cooling tunnels and is sorted by grain size: fine sugar for baking, coarse sugar for candy and cereals, and powdered sugar for icing and confections. Finished sugar is stored in massive silos, each capable of holding thousands of tons. From there, it's sent to bulk trucks for industrial clients, bagging lines that fill 1 kilogram to 50 kilogram sacks, and automated palletizers and robotic arms load them onto shipping pallets. Some facilities produce thousands of metric tons per day, enough to supply entire cities or multiple food companies at once. One of the most impressive aspects of sugar production is how little is wasted. Bagasse is burned to power the factory or turned into paper and bioplastic. Molasses becomes ethanol, rum, cattle feed, or yeast extract. Filter cake is spread back on fields as fertilizer. Sugar mills are some of the most circular, zero-waste systems in modern agriculture. Before sugar reaches consumers or food manufacturers, it must pass strict quality control tests. Every batch is sampled and analyzed in on-site labs using polarimeters to measure sucrose concentration, spectrophotometers to test for color and clarity, moisture analyzers to ensure proper drying, and microbiological tests to detect bacteria or mold. Refined sugar must meet international food-grade standards like the ICUMSA color scale for whiteness, Codex Alimentarius for purity and food safety, and ISO certifications for quality management. Any product that doesn't meet specification is either reprocessed or downgraded for non-food applications. Sugar isn't just a kitchen staple, it's a massive global commodity with major economic and environmental impact. Global production exceeds 180 million metric tons annually, with Brazil, India, China, and the United States leading the way. Entire economies rely on sugar exports. In some regions, sugar mills employ thousands of workers and support entire rural communities. But challenges are emerging. Sustainability pressures due to water usage, emissions, and deforestation, shifting demand as consumers reduce sugar intake in favor of alternatives, and growth in bioethanol markets, using sugarcane juice or molasses as fuel feedstock. Factories are adapting by using green energy from bagasse combustion, recovering water from juice evaporation, and implementing AI systems for process optimization and predictive maintenance. The sugar industry is evolving, not just to meet demand, but to do it cleaner, faster, and smarter. So, the next time you rip open a sugar packet or enjoy something sweet, remember the incredible journey it took to get there. From the fields through powerful industrial machines, to the crystal-clear product in your hand. Sugar is more than just an ingredient. It's the result of a highly engineered process, driven by precision chemistry and innovation on a massive scale. And it's all made by machines. If you enjoyed this deep dive, don't forget to like the video, subscribe to Built by Machines, and hit the bell so you don't miss our next industrial breakdown. Have a process or product you want us to cover? Drop it in the comments. We're always watching. Thanks for joining us.